This is the simple linear regression equation where we have the slope, intercept. These are the two parameters which we are trying to find out. Indirectly, we can say we are trying to find out the best fit line. And this is the one independent variable, and this is the dependent variable. The cost function, what exactly the meaning of cost function, I'll explain you today. Uh, the same example we can consider over here, the advertising and the sales. So sales is at x-axis and this is our advertising. So you can consider this as a y and this as a x. So these are the few values you can consider. So I just draw a specific line somewhere over here so you can visualize that this particular point is far away from the predicted line. So this is the predicted line. You can consider this as a y hat or maybe a predicted values. And this is your actual value. So this particular value, you can consider this as your actual values. So we just try to find out the difference or maybe a distance between the actual value and predicted value. So for that, you can somehow call it as a error. Error means is nothing but the actual value minus predicted value. So this is how we can calculate the error for the single value. So if we want to calculate the error for the all the values over here, so this is how we do calculate. So this is the nothing but the distance between the actual value and the predicted value, or in another way, you can consider this as a predicted line. So we do calculate the distance between them, and for that particular distance, we call it as an error. So error is for now sometimes can become negative values, positive value, and if we want to convert that error into the some magnitude of the positive value, there are two ways to do that. So two ways means error. We can either this is how we can calculate the error. Y means actual value and y hat means predicted value. And if we want to calculate the magnitude value, so there are two ways. One is we can do the moduli of y minus y hat, or maybe we can do, sorry, y minus y hat square. So these are the two different ways which we can convert this error. So error can become a negative value. So if we do not want the negative values for the error, so if you want to convert that negative values into the some positive magnitude, these are the two ways. Using that, we can calculate the distance. So magnitude, or maybe in another terms, you can call it as a distance. So let's discuss what exactly the meaning of cost function and why exactly the requirement of the cost function, and what is the difference between ordinary least square method and the cost function. So cost function is nothing but the function with the help of we do calculate the loss, or maybe you can consider this as either loss or maybe a cost. These are the two same terminology. This is nothing but it's just a synonym of the loss and cost. So these are the like basically two same values. So sometimes some people say cost function, sometimes some people say loss function. So loss function, why exactly the requirement of loss function? Suppose you have built any linear regression model or any machine learning model. You cannot say that whatever model you have built is always a perfect model or maybe a good model. You actually need to tell them your model is good or maybe not, using the some formula or maybe some functionality. In other another terms, we can call it as an error. So based on an error, we can able to understand how good your model is. So that's why we have plotted this particular line, and we are trying to find the distance between the actual value and the predicted value. Actual value, you can consider this as a y test values, and this particular line you can consider the y pred values. So y pred is the predicted values. and these are the actual values, and we do calculate the distance between the predicted values and actual value. For that we do call as a error, and then error we need to convert into the magnitude, either this or this. Let's consider I have converted the entire error into the squared function. So how exactly the loss function we define for linear regression is this. This is the error, so we do need to, and suppose let's consider we have the m values. So for the one value we do know that how exactly we can calculate the error, actual value and predicted value. Let's consider this as a uh, y1 minus y1 had. So this is how we can calculate for the single value. Suppose I want to calculate for the each and every value, and let's consider these are the em points. So this can be y1, this can be y2, this can be y3. So these are, let's consider the ym values. So we need to calculate the error for the each and every value, and we need to do the summation for that. And calculating the error, we either use this technique or maybe this technique just to convert into the magnitude. So that's why the loss function will become something like that: yi minus y hat square I is equal to 1 to m. Let's consider we have the m points. So in another terms you can consider something like y1 minus y1 hat square plus y2 minus y2 hat square plus ym. So we have the m, so that's why we do the summation. Summation is so like sigma function. You can call this as a summation from 1 to m values. That's why I have put it here and y I had square. But we need to calculate the cost function. So that's why we need to add or maybe average out to the some values. So that's why we do the average something like that to m. So this is the cost function for the linear regression, or maybe a loss function for the linear regression. We did over here squared values. That's why we put 2m over here. Alternative cost function. Alternative cost function can be, you can consider something like is equal to 1 divided by m summation I is equal to 1 to m mod of yi minus y hat. So this is an alternative cost function or maybe error function. And in there are like almost 4 5 functions which you can use when you are working on linear regression. Let's consider the third one. So it can be a mean error, mean square error. So mean square error, we just calculate the mean. So it's again becomes something like this because squared error of the mean. And another one is the root mean square. This root mean square means in another nomenclature root mean squared error. So this is how we do assign the nomenclature for that. And this can be calculated. It's just the root values of the mean squared errors. So over here you can consider summation of yi minus y I hat bracket square. Obviously over here I is equal to 1 to m, and then divided by how many values we have, or maybe we have m values. So something like that, and mean square will be so only this particular value. This this can be a fourth one, loss function. This will become just this of yi minus yi hat bracket square divided by m. I is equal to 1 to m. So these are the 4 loss functions. So these are the loss function or maybe a cost function. These are the only function which can help you to calculate the whatever line you have selected using OLS method. So what exactly the difference between the cost function and OLS is? OLS will just give or maybe help you to choose a baseline. So once you choose a line, for example, let's consider this is the line one which your OLS function had choose, and once you choose the line, of this particular OLS function, and this particular OLS or maybe another terms, like suppose we are talking about machine learning. So in a machine learning, in another term we do call it as a gradient descent method. So gradient descent method is in general method, but when we are talking about the linear regression, you can call this particular method as a ordinary least square method. So ordinary least square method is a method which can be used to minimize your cost function. So our job is to minimize our cost function. Obviously, we want to minimize this particular distance. So minimize the distance between one value, uh, or maybe one error. Instead of that, I will call this as a minimizing the summation of this entire uh, error terms or maybe error distance. For that, we will call this as a, when I actually talking about the yum values, let's consider that particular function as a cost function. So I want to minimize my cost function. So what exactly the method of minimizing the cost function is? OLS method. So OLS will help you to minimize. Cost function will just give you the answer what exactly your error is. But suppose I want to minimize that particular OLS. For that, I need to choose the best parameter. Best parameter, when we are talking about the linear regression, we have two parameters. One is the slope and one is the intercept. So intercept means like where my line, this particular line is intersecting, and slope is the line's slope. So these are the two parameters I want to optimize, or maybe I want to find the best parameters using the OLS method. Once I find the best parameter, ultimately we are minimizing our loss function. So is that clear, guys? What exactly the difference between the loss function and the loss function, or maybe a cost function and the OLS method? Can see the cost function is denoted as the error function, and the method finding the parameters of the model, we do use the ordinary least square method to find the best parameter. And the cost function is nothing but which usually just give us the best or maybe a value of whatever line we have choose using the ordinary least square method. So that's the basic difference between the cost function and OLS method. So in OLS, just is a method of choosing the best parameters, and cost is just calculating the parameters. Using the OLS, we are trying to minimize the cost function. So in another way, you can remember something like that is OLS is basically method which help us to minimize our cost function, and cost is nothing but the error. So we have like in our prior lecture, we have actually just seen how exactly we can visualize our data set, how to do the training and testing, splitting of our data set. Once we have done, so LM fit method in the backend, we are using the OLS method to choose our best line for our model. So the predict function is basically used to predict the or maybe calculate the y predicted. So our next job is see what exactly the difference between the y test value and y predicted value. So for that, we are going to use this loss or maybe a cost function. So cost function I already explained. One you can use either mean square error or maybe root mean square error. So these are the main different uh, loss functions or maybe cost functions we have. So using again sklearn library, we can import that mean squared error functionality or maybe a one of the user defined function from that particular library, that will that particular library or maybe a function that would help you to calculate the errors between the actual value. Y test is nothing but the actual value. I'll just write somewhere over here. Your Y test is nothing but the actual values. And your I need to rerun the entire Jupyter notebook one more time. So predicted is equal to your predicted values. Using this root mean square and this MSE means mean squared error or maybe a root mean square, we are just trying to calculate the uh, difference, or maybe we are just trying to calculate the error or maybe a mean squared error of your actual values and your predicted values. So those values we have already defined over here. So this is what we are just trying to find out using the this root mean square, the difference between the actual and predicted. So this is the one of the method. And another method is again R square method. So R square method is not actually a method or maybe a cost function. It's just a method which actually giving you performance of your or maybe evaluation of your model, how good your model is. So R square is actually just trying to find out the variation or maybe total variation which you have got from your data set. So R square value has to be as much as close to 1, and this particular error. So error is some like something terminology you can also understand, that error has to be as small as possible, so that we can say that whatever model we have built or whatever model you have built is a good model because you have achieved like less error out of it. And R square error is the total variation or maybe explanatory variation which you are getting from your results, and that has to be close to 1 or maybe close to 100%. So this is the another scatter plot of the your predicted values and your actual values. So you can see that suppose somewhere over here you have your predicted line predict, and these are the values are little away from your predicted values. So this is how you can also visualize using the scatter plot.